in order to have access to vector and matrices. And I'm going to import a new library. The first one, import network X, S, and X. This library is used to generate graphs. Later on, we will see it in practice. And we are going to import another function from NLTK dot cluster dot util import cosine distance. This is the function that we are going to use to calculate the similarity between sentences. Let's run this code. There is one error here. NLTK, run again. Now we are going to download this package in order to have access to sentence tokenization and also to have access to the stop words. Let's run this code. I will create this variable, stop words, and we are going to get all English stop words. We can take a look at some words that we are going to remove. Then we have this preprocess function, which is exactly the same we implemented before. We are converting the texts to lowercase. After that, we go through each one of the tokens, we append to the list, and then we remove the stop words and also we remove the punctuation. Let's create this function. We already have this sample text, which is exactly the same we used in other case studies. We are removing the empty spaces here using regular expressions. Let's run this code. And finally, we can take a look at this text that we are going to use to test the algorithm. And in the next lecture, we are going to start implementing text summarization. See you there. Hello and welcome to this lecture where we are going to start implementing the function to calculate the similarity between sentences. The first step of this algorithm is to calculate how similar a sentence is to another. Let's open a new cell of code and I will create a new variable, original sentences equals, let's define in the format of a list. I will create this new variable, sentence, for sentence in NLTK.send tokenize, and let's put here our original text. Let's take a look at this variable, original sentences. See here that we have sentence by sentence. Now we need to preprocess them, so we are going to create another variable, formatted sentences. Let's define again in the format of a list. Let's call the preprocess function. I will specify the parameter, the original sentence, and now let's implement a for loop for original sentence in original sentences. So this for is going through each one of these sentences here in this list of sentences. We are copying to this variable and then we send to the preprocess function. Let's take a look at the results, formatted sentences, and now we can compare the results. Here we have the original sentences and here the formatted sentences. Just a reminder that we are converting to lowercase, removing punctuations and also removing the stop words. Now let's create a new function, def calculate sentence similarity, and it will receive as parameter sentence 1 and sentence 2. The goal of this function is to return a number which will indicate how similar sentence 1 and sentence 2 are. The first step, we need to get all the words from sentence 1. Let's create in the format of a list. I will define this new variable words for words in NLTK dot words tokenize, and let's send as parameter sentence 1. This code here is going through each one of the tokens that we are going to send. For example, if we send this sentence here, this for will access each one of the words. Now we need exactly the same codes for sentence 2. I will copy and paste here. Let's change the name, words 2, and let's go through sentence 2. Let's print words 1 and print words 2. I will create this function. Let's open a new cell of code. Let's call calculate sentence similarity, and I will specify the first sentence, formatted sentences, position 0, and the second parameter will be formatted sentences, position 1. So we will measure similarity between position 0, the first sentence, with position 1, the second sentence. Let's run this code. There is one error here. There is a typo in the function, tokenize. Let's correct this here and here. Run the function again. Let's call it and take a look here that we have the words regarding sentence 1 and the words regarding sentence 2. But take a look here that we have the word intelligence and again the word intelligence in the same sentence. And also the word artificial is in the first sentence and we can see this word in sentence 2. So now we need to get unique words instead of these repetitive words. In order to do that, let's create another variable. All words equals, let's define a set. When we use this data structure in Python, we specify the lists, and then it will take only unique values. Let's put here words 1 plus words 2. And here at the beginning, we need to convert to the list format. Let's print all words. I will put this code in comment, create the function again. Let's call it. Take a look here that now we have only unique words. For example, the word intelligence is appearing only once here. And the same for the word artificial. It is appearing only once here. And in the next lecture, we are going to continue this function. See you there. Hello and welcome to this lecture where we are going to continue the implementation. Implementation of the calculate sentence similarity function. Last class, we specified sentence 1 and sentence 2. The goal is to calculate the similarity between both sentences. And see here that in last lecture, we got the unique words considering both sentences. Now we need to create a vector for each one of the sentences. There is this link here from Wikipedia about cosine similarity. Take a look here that this mathematical calculation is a measure of similarity between two non-zero vectors. So we need to convert our sentences from strings to vectors in order to be able to calculate the similarity between them. We are not going to see the step-by-step mathematical calculation because it is not the focus of the course. And it is quite complex, and you can see the equation here. So in order to calculate similarity between two vectors, we need to apply this equation here. If you want to know...
So the sum up to infinity a times b over the distance between a and b.
More details, this mathematical background, I encourage you to read this article from Wikipedia. Let's continue the implementation. Now we need to define two vectors. The first, this article from Wikipedia. Let's continue the implementation. Now we need to define two vectors. The first vector is related to sentence 1, and at the beginning, we will build a vector composed only of zeros. So let's multiply 0 by length all words. Length all words equals 1, 2, 3, 4, 5, 6, 7. There are 7 unique words, and we are building this vector according to the number of unique words. Let's do the same for vector 2, 0 times length all words. Let's print both vectors, print vector 1 and print vector 2. Let's run this code, call the function again, and take a look here that we have two vectors, and the goal is to calculate similarity between the first vector and the second vector. It's important to emphasize that in order to perform the mathematical calculations, we need to convert from strings. These texts here must be converted in a way that we can apply the mathematical equations. So we are converting it to a vector, and now let's move on to the next step. I will implement a for loop for words. In words 1, we are going through each one of the words that are in this first list here. Let's put this code into comments. I will create the function again. Let's call the function. See here that we are going through each one of the words regarding the first sentence. And now we need to check if the unique words are in this sentence. Let's uncomment this code here, run again. See here that the first word is human, and it appears only once in this sentence. So the value for this human word will be 1. Regarding the second unique word, study, it doesn't appear in the first sentence, so the value will be 0. Then we move on to the next word. intelligence, take a look here that this word appears twice. So the value for this word intelligence will be 2. The word agents is not present in this sentence, so the value will be 0. The word intelligent is not present, the value will be 0. Word artificial appears only once, so the value will be 1. And finally, the word like appears only once, so the value for this word will be also 1. This is a very common technique used in natural language processing to convert from text to numbers, and this format is called bag of words, when you count how many each one of the words appears in the texts. Is quite similar to the calculations regarding the frequency-based algorithm. And in order to count the words, we can access our vector 1, which at the beginning is composed of only zeros. We can access all words dot index, then we specify the words plus equal 1. And in order to better understand this part of the code here, I will just copy this part here, open a new cell of code. I will create this test variable. To access the index, we can type test index, and when we specify the word, for example, study 1 was returned because this is the index of this specific word, index 0, index 1. If we type here agents, number 3 was returned, position 0, 1, 2, and finally position 3. So we are accessing the index of this vector to fill the vector 1 variable. Let's print vector 1, run the code. Let's run again just to see the results, to be easier to visualize. Let's uncomment this code here just to check. The word human appears only once. Because of that, we have number 1 here. Then we move on to word study. It is not present, so the value is 0. Word intelligence, 1 here and another here. Value equals 2. Then we move on to word agents and intelligence, 0 because this word is not present. And finally, artificial and like appears only once. Because of that, there are 2 ones here. And now we need to implement the same code, now considering words 2. Let's access vector 2. all words, but index words plus equals 1. Let's print vector 2. I will put this code in comments, and let's put this other in comments. I will uncomment, and let's put this, I will put this. Now considering words 2, let's access vector 2, all words, but index words plus equals 1. Let's print vector 2. I will put this code in comments, and let's put this other in comments. I will uncomment words 2 just to check the results. Run the code again. Now we are visualizing the second sentence. The word human is not presenting the results. I will uncomment, and 2 equals word. Now considering words 2, let's access vector 2, all words, but index words plus equals 1. Let's print vector 2. I will put this code in comments, and let's put this other in comments. I will uncomment words 2 just to check the results. Run the code again. Now we are visualizing the second sentence. The word human is not present here. 0. The word study only once, associated with number 1. The word intelligence is not here. Number 0. Agents, intelligent and artificial. We can see here. Agents, intelligent and artificial. 3 ones here. And finally, the word like is not present because of that number 0 is here. So this is how we can convert a set of words into vectors in order to calculate cosine similarity. Now, the last step, let's return, and I will call the function cosine distance. Just a reminder that we'll take both vectors and use that mathematical calculations that we saw in this link here. And we need to send vector 1 and vector 2. Let's run this code, calculate similarity, see that the value is 0.81. And this value goes from 0 up to 1. So the higher the value, the greater the similarity between sentences. And we can see we have a high number here because there are some common words here. For example, the word artificial is present in both sentences. We can try to calculate the similarity between the first sentence and this other sentence here, related intelligence behavior. There are no common words between them, so the similarity will be small. The position of the sentence is 0, 1, 2, 3, 4. So let's call the function calculating similarity between 0 and 4. See here that similarity equals 1. It would mean that both sentences are exactly the same. And in order to have higher values considering greater, the function calculating in the first sentence and this in both and vector 2. Let's run this code, calculate similarity, see that the value is 0.81. And this value goes from 0 up to 1. So the higher the value, the greater the similarity between sentences. And we can see we have a high number here because there are some common words here. For example, the word artificial is present in both sentences. We can try to calculate the similarity between the first sentence and this other sentence here, related intelligence behavior. There are no common words between them, so the similarity will be small. The position of the sentence is 0, 1, 2, 3, 4. So let's call the function calculating similarity between 0 and 4. See here that similarity equals 1. It would mean that both sentences are exactly the same. And in order to have higher values considering greater similarity between sentences, we need to implement an additional code 1 minus cosine similarity, because this function returned the inverse value. Let's run again. Now, there is no similarity between both sentences, because there aren't common words between them. So, similarity equals 0. They are completely different. Now, let's put again 0 and 1, and we will have another value, 0.18. So, this is the similarity between both of them, and not that value of 81%. So, the similarity between sentence 0 and sentence 1 is 18%. Now we can check the similarity between other sentences. For example, between 0 and 2, let's take a look here. 2 is this sentence here. Take a look that there aren't common words, so similarity will be 0. We can take a look here, the result is 0. Let's try this one here, solve problems, intelligence. There is only one common word. Let's change here to index number 3, run this code. The similarity between sentences are 43%. And if we type here sentence 0 and sentence 0, let's run this code. Similarity is 99%, or if we round this value, similarity will be equal to 1. So it means that sentences are exactly the same. When you have the same sentence, we are comparing the same vector. In this part here, vector 1 and vector 2 will be exactly the same, and consequently, the similarity between them will be 100%. And this is the way we can measure similarity between sentences. And in the next lecture, we are going to create a function in order to create the similarity matrix. So we need to calculate similarity between the first and all other sentences. Then we need to move on to the second sentence and calculate similarity between the second and all other sentences. Then we need to move on to the next sentence, the third one, and calculate the similarity between it and all other sentences. See you there. Hello and welcome to this lecture, where we are going to implement a function in order to create the similarity matrix. So we need to go through each one of these sentences here. Of course, they are converted to vectors and calculate the similarity between the first and all the others, between the second and all the others, between the third and all the others, and so on. And I put this text here just to recap. The higher the value, this value here, the greater the similarity between sentences. See that when we specify 0 and 0, it is calculating the similarity using the same sentence, so the value will be 0.99, or we can round it to 1. The more words in common in the sentences, the greater the similarity between them. Let's define a new function. Calculate similarity matrix. It will receive as a parameter all the sentences. And first, let's initialize the matrix with zeros. I will create a new variable, similarity matrix equals np dot zeros, and now we need to specify the number of rows and the number of columns of this matrix. And I will type here length sentences, and the second parameter also length sentences. See here that there are 1, 2, 3, 4, 5, 6, 7, 8. So we are defining a 8 by 8 matrix, 8 rows and 8 columns. We can take a look at this matrix. Print similarity matrix. I will create the function. Let's open a new cell of code, and let's call the new function calculate similarity matrix, and let's send here the formatted sentences. Let's run this code. calculate the similarity between the first and all the others, between the second and all the others, between the third and all the others, and so on. And I put this text here just to recap. The higher the value, this value here, the greater the similarity between sentences. See that when we specify 0 and 0, it is calculating the similarity using the same sentence, so the value will be 0.99, or we can round it to 1. The more words in common in the sentences, the greater the similarity between them. Let's define a new function. Calculate similarity matrix. It will receive as a parameter all
Ah.
the sentences. And first, let's initialize the matrix with zeros. I will create a new variable, similarity matrix equals np dot zeros, and now we need to specify the number of rows and the number of columns of this matrix. And I will type here length sentences, and the second parameter also length sentences. See here that there are 1, 2, 3, 4, 5, 6, 7, 8. So we are defining a 8 by 8 matrix, 8 rows and 8 columns. We can take a look at this matrix, print similarity matrix. I will create the function. Let's open a new cell of code, and let's call the new function calculate similarity matrix, and let's send here the formatted sentences. Let's run this code. See here that we have 8 rows and 8 columns. Each one of these rows represents a sentence. So now we need to calculate the similarity. The first row is related to the first sentence, and this value here is the similarity between the first sentence and itself. The second value, the similarity between the first sentence and the second, between the first and the third, between the first and the fourth, and so on. Regarding this second line, this value here is the similarity between the second sentence and the first sentence, the second sentence and itself, the second sentence, and the third, the second sentence, and the fourth, and so on. This line here represents the similarity between the third sentence and all other sentences. This number, the similarity between the third and the first, between the third and the second, and so on. Now we need to calculate all these values calling the function we defined here. See that it receives as a parameter two sentences and it will return the similarity value. Let's implement a for loop for I in range length sentences. This first for is going through each one of the rows, and now we need another for loop, an inner for j in range len sentences. This other for is going through each one of the columns. If I equals j, we are not going to calculate the similarity because it makes no sense to calculate similarity between the sentence and itself. For example, this value here represents similarity between the first and the first. So when I equals j, we are at this position here, so we are not going to calculate this value. Regarding the second sentence, this value here represents regarding the second sentence and itself. For example, this value here represents similarity between the first and the first. So when I equals j, we are at this position here, so we are not going to calculate this value. Regarding the second sentence, this value here represents similarity between the second and the second, so we are not going to calculate this value. And in order to not execute the codes, we can simply type continue, so it will not execute the code that we are going to type now. Let's access our variable similarity matrix, position I and position j equals, and let's call calculate sentence similarity. I will send sentence position 1 and sentence position j. We are accessing the list of sentences, which are the formatted sentences. It will receive the preprocessed text. We'll perform all this code here, and at the end we will have the value. Finally, after the for loop, let's return the similarity matrix. I will create this function. Let's call it, there's a typo here, add s sentences, which is this parameter here. Create the function again, run again, and now we have the similarity matrix. Again, these are the similarities between the first and all other sentences. For example, the first and the first, 0. The first and the second, 0.18. We can also test here just to check the values. 0 and 1, the value is 0.18. Then the first with the third, no common words, so the value is 0. Then 0.43, the first and the fourth, and so on. And here we can see the values considering the first with all the other sentences, the third, all other sentences, and so on. So later on, we are going to use this similarity matrix in order to calculate the score for each one of the sentences. We are going to implement this step in the next lecture. See you there. Hello and welcome to this lecture, where we are going to implement the last function, which is the one to summarize the texts. We are going to use this similarity matrix in order to calculate scores for each one of the sentences. Let's open a new cell of code. I will create a new function, def summarize. It will receive as a parameter the text and also the number of sentences. The first step, we need to get the original sentences, so we will implement a code quite similar to the one we implemented before. We need to go through each one of the sentences. For sentence in NLPK dot send tokenize, and we will put here the text. We're going to send the original text and do all the pre-processing. After, let's create formatted sentences equals, let's call preprocess function. I will specify here the original sentence, this variable I'm creating now, for original sentence in original sentences. We are going through each one of these sentences here. After we have all sentences, we can generate our similarity matrix. equals calculate similarity matrix, and let's send here the formatted sentences. This is the same code we implemented before. Just to make sure everything is working, let's print the similarity matrix, create the function, let's call it summarize, let's send the original text and the number of sentences, only 3 for this text. Let's run. See here that we have exactly the same matrix as before. Now we need to generate a different data structure in order to store these values here. I will create another variable, which is the similarity graph equals nx. This is network x, the package we imported before, and we are going to call this function from numpy array, and here we are going to send our similarity matrix. So we are going to convert from a numpy matrix, this format here, to a graph, which is a widely used data structure to represent data. To better understand it, let's print similarity graph dot nodes and also print similarity graph dot edges. This particular data structure will store the relations between the sentences. For example, this line here represents the first sentence, and the first sentence is related to the second sentence. There is a kind of similarity between them. It is not related to the third sentence. It is related to the fourth sentence, not related with sentence number 5, number 6, and number 7, and the first sentence is related to the last sentence. So this data structure will store the relations, only the relations and not the numbers. Let's run this code. The first print is showing the nodes from 0 to 7. It means the index of each one of the sentences. And take a look here. Sentence 0 is related to sentence 1, as we can see here. Sentence 0 is related to 3, and it is related to 7. This and this other relation here. And sentence 0 is not related with these other ones. So this is the graph format where we are storing the relations between sentences. Let's take a look at sentence 1. It is related to sentence 2. We can take a look at the matrix here. This number here, sentence 2, 3, 4. So sentence 1 is related to 4, and finally it is related to this last sentence. So we have here 1 and 7. And regarding sentence number 3, it is related to sentence 4, to sentence 5, 3 is related to 7, 4 is related to 7, and 5 is related to 7. So we need this data structure to calculate the score for each one of the sentences. Now we need to measure the importance of each one of these sentences based on these connections. So we are going to use a very famous algorithm that was developed by Google, which is the page rank. This algorithm was one of the first efforts in Google, and it became very famous because of this algorithm. Firstly, it was used to return the most relevant results considering web pages. In other words, when you type something in the browser, there is an algorithm which will return the most important web pages. So this algorithm can also be applied to our scenario to find the best sentences. We can take a quick look at this link here. You can see the history and all the calculations. You have here the equations, and if you want to know more details, you have the implementation in Python. See here that we have a matrix which represents the relations. To quick understand this algorithm, it will calculate the relevance of each one of the nodes based on the links. For example, see here that B has the highest score, 38.4, because there are a lot of links, a lot of other web pages are pointing to letter B. So it seems more important because other nodes are connected to it. For example, take a look at letter A. The score is only 3.3 because only letter D is connecting to letter A. And we can take a look at these other nodes here. The score is only 1.6 because there is no connections coming to these web pages. See letter E, the score is 8.1. There are some connections coming to this letter. The second most important is letter C. The score is 34.3. And see that there is only one connection coming from B. There aren't other connections. And the score is high because letter B is the most important. So if letter B, which is the most important web page, is connecting to letter C, it means that letter C is also important. So this is the very quick idea of this algorithm. Of course, we don't need to implement it from scratch because there are a function which will receive as a parameter these connections, and then it will calculate the score for each one of them. Let's create a new variable, scores equals nx. There is this function here, page rank, and let's send here our similarity graph. Now we can take a look, print scores. Let's recreate the function, execute this code again. We can see that node number 0 or sentence number 0 has this score, 0.16. Sentence number 1, 0.14. Sentence number 2, 0.12, and so on. Now we need to order these sentences to get the highest values. And to do that, we can create the ordered scores equals, let's call this function from Python, sorted, and now we need to implement a for loop for I score in enumerate original sentences. This for loop here will return the ID and also the sentence. Just to test this for loop, we can open a new cell of codes, paste it here, and let's print I and score. Let's run this code. See here that we have all sentences. This is sentence 0, sentence 1, sentence 2. So the enumerate function will give an index to each one of the sentences to associate with these values here. Now we can get both values. I will type another code here, scores position I, because we are going through each one of the sentences, and we are going to get the score. So we will go through each one of this dictionary here to get the ID and also the score. I will delete this parentheses here, and we need higher numbers first. So at the end, we type reverse equals true. Now let's print the ordered scores, run this code, take a look here that this is the highest score, 0.21, and here we can see the sentence. Artificial intelligence is related to reasoning in everyday situations, and it has the highest score because of the calculations of the page rank algorithm. It means that this sentence has more connections with others. For example, we can see one connection, 0 to 7, 1 to 7, 3 to 7, 4 and 7, and 5 and 7. So this is the sentence with more connections. After that, in second place, 0.16, artificial intelligence is human-like intelligence. We can see that this is sentence number 0, and we can check the number of connections, 1, 2, and 3 connections. In other words, we have something very similar to this image here. Now we need to get the best sentences. I will create this new variable, best sentence.
Yo, it's Snoop D-O double G, and I'm an English voice from the United States. It's time for you to get your reading superpowers.
Sentences, an empty list at the beginning. Let's implement a for loop for sentence in range number of sentences. We are going through this parameter here. See that we specifies number 3. So we are going through the first top 3 sentences. Let's append to the list best sentences dot append ordered scores, and let's specify here the sentence and position 1, because in position 0 we have the score, and in position 1 the sentence. And finally, let's return the original sentences, the best sentences, and also the ordered scores. Let's create the function, and now we can also put these prints in comments, create the function again, and I will create the variables. The first one, original sentences, the best sentences, and finally scores. Let's call the function and take a look at the results. First, the original sentences. After, let's take a look at the best sentences. The top 3 sentences. Artificial intelligence is related to reasoning in everyday situations. Artificial intelligence is human-like, and it is the study of intelligent artificial agents. We can take a look at the scores. Let's type scores here. The best sentence, the second, the third, the fourth, and so on. And the worst sentence is this other here, learn from mistakes. Just to check, I will recreate the function just to see the results. See that there is no connection considering number 6. Because of that, it was considered the worst sentence. And finally, the last step, we can visualize the summary. I will just paste this code here, which is exactly the same we implemented before, in order to visualize in the HTML format. Let's call it visualize. The first parameter is the title, artificial intelligence. The second parameter, the original sentences, and finally, the best sentences. Let's run this code, and here we can take a look at the summary that was generated by the Cosine Similarity algorithm. And in the next and last lecture, we are going to extract texts from the internet. See you there! Hello and welcome to this lecture, where we are going to move on to the last step, which is the extraction of texts from the internet. The code will be quite similar to the one we implemented before. The first step, we need to install the library, pip install goose3. Let's run this code. You can see here the processing. I will click this button in order to clean the output. Let's import the library from goose3, import goose, create object g, which will be responsible for extract the texts. URL. Let's use the same article from Wikipedia again. And finally, article equals g.extract URL. Let's run these codes. We can take a look at the content article dot clean text. Just a reminder that a good point of this library is that we don't need to preprocess the text to remove the HTML code. Now let's create the original sentences, the best sentences, also the scores equals, let's call the summarize function article dot clean text. Now we need to specify the number of sentences. I will type here 120. Let's run this code, and it will take a longer time to run if we compare to the other algorithms, because the mathematical background, all the calculations are more complex than the other algorithms. We can take a look here at the links between the sentences. Put this line here in comments in order to not show this message. Now let's analyze the results. And again, you can use this equation 120 divided by the length of the original sentences times 100. So when we select 120 sentence, it means that we are getting 40% of the text. Let's take a look at the original sentences. Those are all the sentences in the article. We can take a look at the best sentences, only 120 most important sentences according to the algorithm. And finally, we can see the scores. So it is interesting to see the scores of each one of the sentences. As we have a big text, you can see that the scores are not so high as for the other example where we had only 8 sentences. And finally, the last step, we can visualize the summary. Let's call the function visualize. The first parameter is the title. The second parameter is the original sentences. And finally, let's send the best sentences. Run these codes, and here we have the summary, the original text, and also the most important sentences in yellow. And similar to the other algorithms, we can define a percentage instead of defining the number of sentences. So we can make a small change in the summary function. Let's define this new parameter, percentage. The default value will be 0, and I will simply implement an if statement here. If percentage greater than 0, let's change number of sentences equals, let's convert to int, length formatted sentences times percentage. So we are changing this parameter here, and then we go through according to this value here. If we don't set the percentage, then we will select considering the number of sentences. Let's run this code and try to execute the summary function again. Let's specify, for example, 0.2. It means that we will return only 20% of the original text. Let's run the visualize function, and we can see that it seems that the algorithm is working because there are less sentences that were selected. I don't want to be repetitive, but it is important to say again that there are 2 important points when you work with text summarization. The first one is to define the size of the summary, and it will be based on the size of the original text. So you can use the percentage parameter. The bigger the text, the bigger the summary must be. And it is necessary because if you have a long text and you choose only few sentences, this summary will not be so good because not all important sentences will be returned. We can see an example in this text here. A lot of texts were not selected. And the second important point is that the evaluation of the summary is somewhat abstract. So you need to read only the main sentences and check if you can understand the general idea of the text. So it's a matter of generating the summary and read the text. You can also ask for other people to read the summary for you and ask for their opinion on the quality of the text. And finally, another idea is to create a questionnaire on the original text and check if people can answer the questions by reading only the summary. This is one of the most interesting ways in order to evaluate this type of algorithm. Now that you have implemented 3 types of algorithms, in the next section, we're going to work with some specific libraries specially used for text summarization. See you there! Hello and welcome to this new section of the course. Now that you have learned how to summarize texts using 3 different algorithms, and most important, made the implementations from scratch, it's time to use some libraries. Before using pre-built libraries, it is very important that you first understand the basic of the algorithms, and then you go on to use the libraries. So you will be more comfortable when working on text summarization projects. We will work with 3 different libraries: Summy, PySummarization, and also BERT Summarizer. SUMI uses the most basic algorithms similar to those that we implemented step by step. The second one uses modern techniques of recurrent neural networks, while the third uses the BERT model, which is one of the most advanced and powerful technologies to solve natural language problems. The difference between the first and the other two is that the first uses frequency-based statistical calculations, similar to what we implemented before, while others use datasets so that the neural network learns to identify the best sentences. They are quite this new section of the course. Now that you have learned how to summarize texts using three different algorithms, and most important, made the implementations from scratch, it's time to use some libraries. Before using pre-built libraries, it is very important that you first understand the basic of the algorithms and then you go on to use the libraries. So you will be more comfortable when working on text summarization projects. We will work with three different libraries: SUMI, PySummarization, and also BERT Summarizer. SUMI uses the most basic algorithms similar to those that we implemented step by step. The second one uses modern techniques of recurrent neural networks, while the third uses the BERT model, which is one of the most advanced and powerful technologies to solve natural language problems. The difference between the first and the other two is that the first uses frequency-based statistical calculations, similar to what we implemented before, while others use datasets so that the neural network learns to identify the best sentences. They are quite more complex. SUMI can be used for multiple languages because we basically need to count the number of times the words appear. On the other hand, libraries based on neural networks need datasets in specific languages. For example, if the algorithm is trained for the English language, it is not possible to use it in other languages. For this reason, it is necessary to carry out a new training for each language. And in the next lecture, we are going to start the implementation. See you there. Hello and welcome to this lecture where we are going to implement text summarization using three different libraries. And in the next lecture, we are going to prepare the environment. We already have this Google Colab file. Just a reminder, in order to run or to make changes, you need to click on File, Save a Copy in Drive. When you click this link, a copy of this notebook will be made on your own Google Drive. So you must have a Google account and be connected to it. I will click this button here in order to connect to the Google servers. And we already have this code, which is already implemented. We are not going to implement it step by step because it is the same we implemented before. We are importing NLTK, Natural Language Toolkits, RE, Regular Expression, and we are downloading this package to be able to work with word tokenization and also sentence tokenization. Let's run this code. After that, we are installing the Goose library to read articles from the internet. I will click here to clean the outputs, and this part of the code is accessing this website, the automatic summarization article thing. Create after that sentence tokenization. Let's run this code. After that, we are installing the Goose library to read articles from the internet. I will click here to clean the outputs, and this part of the code is accessing this website, the automatic summarization article, because we are going to perform the tests using the same article as before. Let's run this cell of codes. Just a reminder, to see the cleaned text, we can access these attributes, run this cell. We can see here the text without the HTML code. Just a reminder again, the good point about using this library is that you don't need to pre-process the text to remove the HTML code. Let's create the original sentences. We are going through each one of the sentences and storing them in a list. Let's run this code. See here that we can see all the sentences that were extracted. Finally, we're going to create this function, visualize. As the name suggests, we are going to use it to visualize the results. Let's create this function, and in the next lecture, we are going to use SUMI library. See you there. Hello and welcome to this lecture where you are going to learn how to work with the SUMI library. You can follow this link to see the documentation of the library. And this library is quite interesting because you can use a lot of algorithms. For example, the Loon algorithm, the one we implemented step by step. And the good point is that if you want more details about each one of the supported algorithms, you can follow this link here and you can read the full paper, The Automatic Creation of Literature Abstracts. We can also see some other algorithms like Edmundson Latent Semantic Analysis. This is a very relevant technique used in natural language processing. LexRank, TextRank, both based on the PageRank algorithm, quite similar to the Cosine Similarity we implemented before. And we can also see this other algorithm, SumBasic, which is a method that is often used as a baseline. This is quite similar to the first approach we implemented, the frequency-based algorithm. And again, to read more about it, you can follow this link. Then you can see the original paper if you want to know more details about the algorithms. These references are very interesting if you want to go deep in the area of text summarization. We can see here the supported languages, for example, Chinese, English, French, Portuguese, Spanish, and so on. Now let's go back to our Google Colab file and perform a test using this article we extracted from Wikipedia. Let's install the library, pip install sumi. Let's run this code to install the library. It's quite fast to install it. I will click here to clear the output, and now we need to import some classes. The first one from sumi.parsers import plain text parser in order to read this kind of text here. Then we need to import the tokenizers from sumi.NLP, which means natural language processing, dot tokenizers, import tokenizer, and finally from sumi.summarizers, and I will choose the Loon algorithm. We can see here that list we saw in the website. Let's import the package Loon, and I will import the class Loon Summarizer. Just a correction here, Sunny parsers dots plain text. Let's run this cell. No error was returned, so the library was successfully installed. Now we need to create a variable called parser, and the goal is to read this text here. Let's call the plain text parser from string, because we have the data in the string format, and let's send here article dots clean text. Pay attention that we are not sending these original sentences because they will be used to visualize the results. We need to send to the algorithm the clean text because this object here will tokenize the sentences. We don't need to tokenize them before sending to the algorithm. Now we need to call this class tokenizer, and we need to specify the language, in our case, English. Let's create this variable. The next step, we need to create our summarizer, Loon summarizer. No parameter is required. Let's run this code to create our algorithm, and finally, we can generate the summary. I will create this variable, which will store the results. Let's call the summarizer parser document, and there is another parameter here, sentences count, so you need to specify the number of important sentences you want to select. It is not possible to send a percentage here, so you need to perform that calculation we saw before to define the percentage of the text you want to return. Let's create the summary. We can take a look at the result. Summary, we can see here 120 sentences that were returned by the algorithm. Now we can put all these sentences in a list format to call our visualize function. I will create a new variable, best sentences, and empty list at the beginning for sentence in summary. We can print the sentence. Let's run this code. See here that all sentences were returned, and now we need to append them to the list. Best sentences dot append, and I will specify here the sentence. And we need an additional code because see that we have this sentence text here, so this is not in the string format. To get the results in the string format, we need to specify str here to convert them. Let's create this variable. I will open a new cell of code, and let's call the visualize function. The first parameter is the title. Let's send here original sentences and also the best sentence. sentences. Let's run these codes, and now we have quite similar results to the one we had when implementing from scratch. Now you can read this text to check the quality of the summary. And in the next lecture, we're going to work with PySummarization library. See you there. Hello and welcome to this lecture where you are going to learn how to work with the install the library. It's quite fast to install it. I will click here to clear the output, and now we need to import some classes. The first one from summy.parsers in our summy.nlp in the web import here. So it's a read parser from string because we have the data in the string format, and let's send here article that we because and to the here we'll token sending tokenizer English. We need to operate our call, and there needs to select. So you need to perform that calculation we saw before to define the percentage of the text you want to return. Let's create the summary. We can take a look at the result. Summary, we can see here 120 sentences that were returned by the algorithm. Now we can put all these sentences in a list format to call our visualize function. I will create a new variable. We can sentence summary. We can we can take a look at the result. Summary, we can see here 120 sentences that were returned by the algorithm. Now we can put all these sentences in a list format to call our visualize function. I will create a new variable, best sentences, and empty list at the beginning for sentence. In summary, we can print the sentence. Let's run this code. See here that all sentences were returned, and now we need to append them to the list. Best sentences dot append, and I will specify here the sentence. And we need an additional code because see that we have this sentence text here, so this is not in the string format. To get the results in string format, we need to specify str here to convert them. Let's create this variable. I will open a new cell of code, and let's call the visualize function. The first parameter is the title. Let's send here original sentences and also the best sentences. Let's run these codes, and now we have quite similar results to the one we had when implementing from scratch. Now you can read this text to check the quality of the summary. And in the next lecture, we are going to work with PySummarization library. See you there. Hello and welcome to this lecture where you are going to learn how to work with text summarization using other library, which is PySummarization. You can follow this link to see the documentation, and the most important thing to know about PySummarization is that it is based on LSTM, which means long short-term memory, which is a type of recurrent neural network. They are more complex and efficient techniques. You can take a look here at the description, and if you want to know more detail, you can follow this link here. You will find more information about how to use the library. And as we can see here, we can work with several languages, for example, English, and we can see here more examples with Japanese language. Now let's go back to our Google Colab file. Let's install the library, pip install py summarization. Let's run this code. After the installation is completed, I will click here to clear the output, and now we need to import some classes. The first one from py summarization dot NLP base dot auto abstractor imports the class auto abstractor. This class will be used to generate the summary from py summarization dot. We have this other package, tokenizable doc, to tokenize the sentences, and we are going to access this package, simple tokenizer, import simple tokenizer. This is quite similar to the NLTK tokenizer we implemented before. And finally, the last class from py summarization dot abstractable doc dot top and rank abstractor to give score to the sentences, import top and rank abstractor. Let's run this code. Now we need to create some new variables. The first one I will call auto abstractor equals auto abstractor. Now we need to specify some attributes to this variable. Auto abstractor dot tokenizable doc equals simple tokenizer. We are specifying the tokenizer. The other parameter, auto abstractor dot delimiter list equals, and we are going to specify here dots and also this symbol, which means when we skip the line. Basically, these are the symbols to find when a sentence ends and when another sentence begins. The last variable, abstractable doc equals top and rank abstractor. Let's run this code, and now we can generate the summary. I will create this variable, which will store the results. Let's call auto abstractor. I will call the summarize function, and we need to specify the parameters. The first one, article dot clean text. See here that we send the document and also the abstractable doc. So let's send here that variable abstractable doc. Create the variable. Now we can take a look at the summary. And here are the results. We have a dictionary format, open braces here, scoring data, which means the most important sentences. For example, sentence 0, the score 21, sentence 1, score equals 9, and so on. And in this key here, summarize results, we have the best sentences that were returned. And you can see that in this algorithm, we don't need to specify the number of sentences, because as this algorithm was trained using a recurrent neural network, it will automatically adapt to the size of the text. So it's a good point of this library that you don't need to calculate how many sentences you want to return. Now let's create the list with the best sentences. Best sentences equals an empty list. Let's implement a for loop for sentence in summary, and now we need to access this key here, summarize results. Let's type here, summarize result, just to check. Let's print the sentence, run this code, see here that the most important texts were returned. Now we just need to add them to the list, best sentences, dot append, and let's specify the sentence here. Run this code. Finally, we can call the visualize function, the first parameter, article dot title, the original sentences, and finally, best sentences. Let's run this code, and we can see here that apparently no important sentence was returned here. We have the original text, and it happens because the format of this variable best sentences is quite different from the original sentences here. Let's take a look at some examples. Best sentences. At the end of each one of the sentences, see that we have this symbol to specify that we are skipping a line at the end of each one of the sentences. And if we go back to our visualize function, see here that we are checking if sentence in best sentences, but the original sentence does not present the symbols in order to skip the lines. So we need to remove them in order to visualize the results. So I will make a small change here. I will call re.sub, the regular expression, and we will implement a similar code we implemented before. Bar s plus, let's replace by an empty space. This is the same code we implemented to remove these symbols here. Now let's run again. We need to close another parenthesis here. Run the code again. Let's take a look at the best sentences. Now that symbol was removed from the end of each one of the sentences, let's call again the visualize function, and it seems it's not working yet because now we have this empty space, and when we are comparing the original sentences with the best sentences, they are different because the original sentences don't present the empty space. So we can remove it by calling this function strip. It will remove empty spaces from the beginning and also from the end of each sentence. Let's run this code. Let's take a look at the best sentences. See that we don't have empty spaces any longer. Finally, let's visualize the result. And now we can see the list of the best sentences that were returned by this algorithm. We can see here that less sentences were returned if we compare to the other algorithm, because for the SUMI library, we need to specify the number of sentences we want to return. And when using this other library, the algorithm itself will identify the number of the most important sentences. So now you need to read this text and check the quality of the summary, and then you can compare with the other algorithm. And in the next lecture, we're going to use another library, which is the BERT summarizer. See you there. Hello and welcome to this lecture where we are going to work with text summarization using the BERT summarizer library. You can follow this link to see more details about the library. See that the name of the library is BERT Extractive, so we are working with that technique in which we extract the best sentences. We are not generating new text. Here you can see more details about how this library works. See that it uses PyTorch library, which is a very famous library to work with deep learning. And in this text, we can see how this library works. It applies a clustering algorithm, and then it finds the sentences that are closest to the cluster centroids. It uses the idea of calculating similarity between sentences, similar to what we implemented in this section about cosine similarity. Now let's go back to the Google Colab file. The first step, we need to install the library. Pip install BERT Extractive Summarizer. Let's run this code to install the library. We can click here to clear the output, and we also need to install another library. Pip install transformers equals 2.2.0. This is the version of this library we need to install in order to work with this library. This code is in the documentation of the library. Let's run this code to install transformers library. Let's clear the output. Now we can import the summarizer. From summarizer, import summarizer. Let's run this cell. And now we can create the summary. Let's create the variable summarizer equals summarizer. And now we can generate the summary. Let's call summarizer. And the only parameter we need to specify is the text, article cleans text. Similar to the PySummarization library, we don't need to specify the number of sentences. Let's run this code. And as this algorithm is quite more complex than the others, it will take some time to run. Then we can check the summary. Let's call this variable. And here we can see the summary, and this is not a list, it's a plain text, and now we need to convert to a list format in order to call our visualize function. I will create another variable, summary, tokenized, open and close brackets, sentence for sentence in NLPK dot send tokenized, and let's send here the summary. We can take a look at the summary, tokenized. Let's run this cell. Now we have the best sentences in the list format. And the last step, we can visualize the summary. Let's call the function visualize. The first parameter, article dot title. The second parameter, the original sentences. And the summary tokenized. Let's run this code. And again, the good point about this library is that we'll automatically select the best sentences. You don't need to specify how many sentences you want to select. And again, you can compare these results with the other algorithms to evaluate what has the best results. And that's all for this lecture. See you next time. Hello and congratulations for completing this course on text summarization in Python. In this last lecture, I will quickly recap all the content that was covered. In the first section, you learned one of the most basic algorithms, which is based on the frequency of the words. Then, you learned one of the most classical algorithms, the Loom algorithm, which is one of the most important because other modern algorithms were based on it. Then you learn how to implement summarization using Cosine Similarity and also the PageRank algorithm developed by Google. Finally, in the last part of the course, you learned how to use some libraries instead of implementing the algorithms from scratch. For example, library Summy, PySummarization, and also the Bird Summarizer. And just a reminder that the focus of this course was in NLP techniques based only on natural language processing, and we didn't cover deep learning techniques. And also, we worked with the extractive approach, where you can see here we have the original text and we select the best sentences. I really hope you enjoyed the course and feel more comfortable to take advanced course on this subject, especially techniques based on neural networks and deep learning. Thank you and see you in the next course.
Hi there, we are AI Expert Academy, an online platform where you can learn about artificial intelligence and data science. We believe in an online learning environment that allows for an ongoing continuous education. For this, we have membership plans which give you full access to all our online courses, each with its own certificate. For a fair monthly price, you have high-quality educational videos available on a variety of topics such as machine learning, deep learning, computer vision, natural language processing, artificial intelligence algorithms, and so much more. We are 100% confident that you will have a useful, practical, and complete learning with our unique demonstration method, giving you a much deeper understanding of any particular topic. Our courses are created in collaboration with great educators who are passionate about sharing their expertise. Right this very moment, a new online course is being produced, keeping to our commitment of providing new content to our students every single month. We guarantee with absolute certainty that you will never have to stop learning. Find out more about a wide range of courses on artificial intelligence and data science. Access aiexpert.academy.
That's all, folks. Now I'm about to do Ionic. Let's get into it.